Hey guys, this is the notes and video for 2.8. Now I know there are a lot of formulas in this section. There's formulas in 2.7 and 2.6 and 2.5, so feel free to print my notes, save them in a binder, and then you have them for when you do homework or tests and such, okay? So here is 2.8. It's on the present value. Now in 2.7 we looked at future, what something's going to be worth years from now. Present value can tell us the value right now of what we need to deposit right now. So there are two kinds, okay? So there's the present value, and I'm going to put, I'm going to use shorthand and put PV for present value, okay? I'm going to abbreviate just so that every time I'm not having to write present value, okay? So PV will be for present value. So there are two formulas: the present value of a single deposit. So this is a one-time deposit. You put money in the bank, you walk away, you don't put anything else in the bank. So the present value of a single deposit has one formula, and it looks like this. The present value is our balance divided by, and it's gonna look similar. It's the part that was in parentheses, that 1 plus r divided by n to the n times t. Okay, so it should look familiar, all of those pieces. P stands for present value. B would be your ending balance. Okay, so remember, B is the ending balance. Now, there's another formula. So this would be if I deposit money in the beginning and then I walk away and I don't deposit anything else. Or there's present value of a periodic deposit. Now, periodic means you make repeated deposits. So this would be if you decided, oh, okay, I'm going to deposit $100 every month or $5,000 every year. Repeated, it happens again. And that formula looks very different. So the present value of that equals your balance times the rate divided by n all over 1 plus the rate divided by n to the nt minus 1. Okay, I will help you simplify each of these, so make sure you have a calculator. So go ahead and grab your calculator and work out some of these examples with me. So I'm going to try to use shorthand when I write down these word problems because I know no one's a fan. All right, so let's say that Mike was saving money for his daughter's wedding. Mike wanted to save $30,000 by the end of 20 years. The account yields 3% interest. I'm using shorthand, compounded annually. Okay, how much should he deposit now? So the reason why this isn't a future value is because he's not asking what will be in his account 5 years from now. He's asking, what do I deposit right now? And that's why this would be called present value. Now, we're going to use one of these formulas, but it depends on how often he's making a deposit. It sounds like it says, how much should he deposit now? So he's not saying how much should he deposit every month or how much should he deposit every week. It's just how much should he deposit now. So this is a single deposit. And I know that it's present value because it says now. So I know he's asking about the present value. So because it's a single deposit, I'm going to use the following formula that I wrote above. The present value equals our balance, which she already said, divided by that part that's usually next to the principal, right? 1 plus, or you can think of P as principal, initial deposit, present value, R divided by N to the N times T. So in this case, let's highlight the things that are important. There's your balance. Here's my interest. Annually, hopefully you have those memorized by now. Annually means, I don't know why I was going to write an A, means that N equals 1. So here's my formula. I have 30,000 divided by 1 plus my rate, which is 0.03, over 1. And it says, 20 years. There's my time, right? That would be 20 times 1. Now, do we need to enter ones? No. So I have 30,000. I'm simply going to enter 1 plus 0.03 to the 20th power. So I'm going to enter this in my calculator first. Okay, so, parentheses 1 plus 0.03 to the 20th power. Okay, and I'm going to record a lot of that, so that gives me 1.80611, and on the top I have 30,000, and then I'm going to divide to get my final answer. So 30,000 divided by 1.80611, and I get $16,610.28. Now, I want you to be really careful in these problems in the computer. So let's say they want us to round to nearest dollar. Okay, nearest dollar means your answer shouldn't have any cents. So if I was to round to my nearest dollar, that means 28 cents is not going to round that up. So I should deposit $16,610. Okay. Number 2. All right, so how long you know what, I'm not going to ask that one because that doesn't have to do with today's section. Okay, so let's say someone's going to be attending 4 years of college plus 4 years of graduate school. If you want $200,000 in 8 years, how much must you deposit now at 2.6% interest compounded monthly to meet the goal? And I want us to round to the nearest $100. All right, so let's talk about this equation. I want 200,000 in 8 years, because 4 plus 4. Here's my interest rate monthly, and it says how much must I deposit now. So that's how I know I'm talking about present value. And it sounds how much must you deposit right now is a single deposit. So again, I'm using that single deposit formula. So what must I deposit now? That's P. I want a total of $200,000 balance in my bank. Monthly, remember monthly means that n equals 12. So my formula is 1 plus my rate, 0.026, divided by 12. My exponent should be 8 times 12, or you can simply put 96. So we're going to enter the bottom first. We're going to simplify the bottom, right? We're going to enter all of this down here. So using a calculator, parentheses 1 plus 0.026 divided by 12 to the, now if you're going to enter 8 times 12, you need to put it in parentheses. So 8 times 12, parentheses, and I get 1.2309. And the more decimals you keep, the more accurate your final answer will be. And this has to do with your money, so be as accurate as possible. So now 200,000 divided by 1.23094, and I get $162,477.46. Now they said to round to the nearest $100. Well, here's 162,400. So that's the hundredths place. 1, 10s, hundredths. So if you say it out loud, it'll help. $162,477. They want us to round to the nearest 100, which would mean him. So you always look to the number to the right. So 7 would round it up. So I'm going to deposit $162,500. Right? We don't care about pennies or anything like that. So that's what it means to round to the nearest 100. All right, next one. I'm going to try to use shorthand. So Kate wants a pool in 5 years, like an in-ground pool. Sorry, you can't see that. Cost is $50,000. How much should she deposit monthly into an account that pays 1.6% interest compounded monthly so that she has enough money in 5 years, and we're going to round to nearest dollar. All right, so this is present value because she wants to know how much I should deposit right now. But notice she says how much she should deposit monthly. So it doesn't just say how much should she deposit now. She's saying deposit monthly. So that right there tells me this is a periodic deposits because she's making multiple deposits or deposits each month. And that's a different formula. That's principal equals balance times rate over n, all divided by 1 plus r over n to the n times t minus 1. So that is the second formula I gave you right here. Okay? And I'm using that because I'm making more than one deposit. So let's see here, 5 years, 50,000, where there's my interest rate, compounded monthly, so I know that n must equal 12. So let's fill in our formula. She wants a balance of $50,000 times my rate, which is 0.016 divided by 12, all over 1 plus my rate, so it's this part again. I have an exponent, though, of 12 times 5 and then minus 1. Now, how you enter this in your calculator is super, super, super important. So the first thing I'm going to enter is this, because I need to do this before I multiply it by 50,000. The second thing that is most important is I'm then going to enter this part. Okay, so let's do those one at a time. So 0.016 divided by 12. Okay, so I'm going to rewrite the top. The top is now 50,000 times 0.00133, right? That's repeated. All over, and now I'm going to enter this yellow part. So parentheses 1 plus 0.016 divided by 12 to the 60th power, because 12 times 5 is 60. Okay, and I'm going to subtract 1, right, minus 1, and I get 0.08323. So now I'm going to simplify the top, so 50,000, I'll keep wanting to say 500,000, times 0.001333. Okay, and I just get 66.65 divided by 0.08323. And I get $800.80. Now, remember, this was asking how much should she deposit per month, okay? So for 5 years. So I'm going to round to the nearest dollar. So when I say this, 801 would be the nearest dollar. They don't want cents. So this would round it up. So she needs to deposit $801 per month for 5 years in order to save up for a pool. Next one. All right, so let's do this one. If I want 100,000 in 25 years, my account yields 1.75 interest, compounded weekly. Well, we'll do monthly. How much should you deposit each month? So again, I know this is a periodic deposit because it says deposit each month. So I know I'm going to use the formula for periodic deposits. So P equals, so the first thing I'm going to write is my balance. I want $100,000 in my account times my rate divided by N, which again is 12. So here's B, time, interest rate, compounded monthly. And I'm going to divide all of that by 1 plus my rate divided by 12. And up here I said it should have 25 times 12 and then minus 1. Now remember, the things we're going to do first, I'm going to evaluate this and then I'll evaluate that. So I have 100,000. Let's enter this in my calculator, 0.0175 divided by 12. And I get 0.00146. The bottom, parentheses 1 plus 0.0175 divided by 12 to the, I don't know what that is in my head, so I'm going to do 25 times 12. Notice 25 times 12, though, is in parentheses. Hit enter, then hit minus 1. And so I've got 0.54834. So I'm going to keep simplifying. Now I'm going to enter the top. So 100,000 times 0.00146, and I get 146, divided by this decimal. So 146 divided by 0.54834, and I get $266.26. Now let's round to the nearest dollar. So does 26 cents round that to 267? No. So $266 per month. Not so bad, but it's also because you're talking about 25 years from now. Okay. So next one, and I think it'll be our last one. Okay. So here we go. Maybe I can, no, I probably can't. Let's fit it right here. This will be our last one. So Anthony wants to repay family in 3 years. How much does he need to deposit? Semi-annually. I really wish I could write as fast as I could talk. Into an account that pays 1.25% interest twice a year. The loan was for $35,000. Round to the nearest dollar. All right, so he wants to pay his family back in 3 years. It said that he wants to deposit semi-annually. Here's my interest rate, and here's the loan. Okay, so let's set it up. What should he deposit if he wants a total of $35,000? Now he's making more, so that is because he's depositing semi-annually, that is a periodic deposit because he's making more than one. Okay? 35,000 times his rate divided by semi-annually is n equals 2. And I'm going to divide all that by 1 plus, it's this exact same fraction. But this is going to be 6, right? 2 times the number of years, which is 3, and then minus 1. All right, so let's simplify this one piece at a time. So 0.0125 divided by 2, and I get 0.00625. The bottom, 1 plus 0.0125 divided by 2 to the 6th minus 1. And I get 0.038091. I'm showing you each of my steps so that you can see where I'm getting each piece. So 35,000 times 0.00625. I got 218 and 75 cents. And now I'm going to divide that by the bottom. And I got $5,742.83. Now, remember, this is how much he's going to deposit twice a year, but it said to round to the nearest dollar. So 5,000, if it helps, say it out loud, 5,743, right? Because the 8 rounds the 2 up, sorry. So he needs to deposit this twice a year for 3 years in order to pay his parents back. So that should cover what's from this section. Now, if you get something on your homework, they do review the future value, so just be careful if it says future value on your homework, getting you to review the formula from last week. Make sure that you use the future value formulas. Okay, so be really, really, really careful on your homework. If it tells you to do future value, these are from 2.7. This is for single deposit. This formula is for periodic. So be really careful. I just didn't feel the need to review last week's already. Goodbye.